We have an exciting presentation for you this afternoon. Today's topic is patient-centered care requires a patient-oriented workflow approach. We have two speakers with us today from WPI. The first is Sharon Johnson, and the second is Mustafa Ozanek. We'll get started in a few minutes. I just wanted to kind of remind the group, if you can put your phones on mute, and we'll have time for questions and discussion at the end after the presentation. Before we get started, I just wanted to briefly introduce our speakers. Sharon Johnson is an Associate Professor of Operations and Industrial Engineering in the School of Business at Worcester Polytechnic Institute, as well as a Faculty Director of the Healthcare Delivery Institute at WPI. Dr. Johnson's current research includes a project funded by the National Science Foundation to explore the effects of the electronic health record systems on care delivery processes. She's also working here with us in the New England VERC, to explore secure messaging workflow and examining work system structures in the context of anticoagulation clinics. Our second presenter is Mustafa Ozanek. He's a postdoctoral fellow at Worcester PI. He's earned his MS and PhD in Industrial and Systems Engineering at the University of Wisconsin-Madison. His research interests include work systems in clinical and non-clinical health settings and organizational and social consequences of health information technologies. He's currently the coordinator of an oral anticoagulation management study, which aims to examine the structural dimension of anticoagulation care delivery. He's also part of the research investigation, which aims to evaluate healthcare team use of secure messaging while delivering patient-centered team-based care. Please join me in welcoming them, and I'm going to turn it over to you now, Sharon and Mustafa. Thank you.
Great. Thank you, Shiragi, for the introduction. I'm going to wait just a minute while our slides come up. Perfect. So as Shiragi mentioned, the title of our talk today is Patient-Centered Care Requires a Patient-Oriented Workflow Model. And if you can move to the next slide. We wanted to start with a vignette, and this vignette is from the book Confronting the Inconvenient Problems of Patient Safety. And in this vignette, which is by one of the editors, Ross Koppel, he talks about an experience he had when his wife was in the hospital and had undergone major surgery, and after the surgery she gets wheeled to her room, or gets wheeled up to the floor with her assigned room, and the computer displays at the nurse's stations indicated that she'd left the post-anesthesia care unit and was now on her floor. And so her husband is waiting in the lobby to find out where she is. He doesn't find out, so then he goes searching through the hospital, and he finds her in a hallway, kind of shivering and dehydrated, near the elevators, just left alone. And so he goes down the hall to the nurse's stations, and they said, well, we didn't know she was here. We knew she was coming, but we didn't realize that she'd been left in the hallway. And so then, of course, they take care of her. So this vignette indicates, sort of demonstrates, if you could move to the next slide, Shiragi, sort of a common problem in healthcare, and one as we look to improve healthcare that we'd like to see eliminated. So we'd like to figure out how to eliminate such incidents. And one perspective that we have, or one component that we believe is part of the answer, is really to adapt a systems perspective, so to treat and look at healthcare as a system and think of it as a system. And so as we adopt that systems perspective, we kind of start with a definition of what a system is. So if I think of a system as being a set of things working together as parts of an interconnecting network, a complex whole, and it comes from the Oxford Dictionary. So if we think about that in the context of the vignette that I just kind of read through, in this system is the surgery and recovery area. There is another part of the system, which is the patient unit or floor. There's another part of the system, which is the IT that's kind of tracking the patient through the system. And then there's also like the patient on the stretcher being transported through the system. And so those are all parts of the system. And the whole system I might think of in this case as being the hospital. And so as I look at and I start thinking about healthcare from a systems perspective, in thinking about the parts being part of an interconnected network or working together, they work together to achieve a goal. So I've designed the system, or I want to design the system to achieve a goal, and so I want to ask the question, what is the goal, and then design the system to achieve that. And in that context, as I think about the goal, I can think about it, as I look at the system, I want to try to optimize that goal across the entire system or globally across the system, and not just for the individual pieces of the system or the local pieces of the system. So again, in the context of this vignette, if I think about global optimization, I want the experience as a whole to be great for the patient as she moves throughout the hospital. Where in actual fact, as you listen to the vignette, there's sort of local optimization going on, and particularly from the point of view of looking at sort of the surgical area, we might assume that their goals were, and I can have more than one goal, but in this case their goals might have been to have a successful surgery. And then also there might be a goal related to resource use. That is, once the patient has recovered appropriately, then I want to move her out of the area onto the floor so that I may be able to use that bed for another patient coming out of surgery. And so what's missing in that local optimization is an understanding of what is going on the floor and whether they're ready to receive the patient. So there's this issue, if I don't look at a systems perspective of kind of locally optimizing things and not globally optimizing them. And then from the perspective of this talk, what we would argue is that, one goal should be the patient experience and patient outcomes and patient-centered care. And as we talk about the patient experience, we're talking not only about clinical outcomes, but also satisfaction-related items such as wait time or things like access. So, Shirag, if you could move to the next slide. So the question is really, how do you introduce a systems perspective into healthcare? And we propose a patient-oriented workflow approach, which is what we're going to be talking about primarily today. So next slide. And the patient-oriented workflow approach was developed by Mustafa with his PhD committee as part of his PhD dissertation. And if I think about that patient-oriented workflow approach, the idea is that I define and model the building blocks of workflow around patients and the care that they're getting, and in particular around a patient care episode. And so the focus is really on what the patient goes through within the care delivery system. So I'm going to be looking at the activities and other work elements, things that are done with and for the patient as they move through a particular care episode. And so I need to be able to characterize a range of activities that are undertaken by multiple people as they provide this care. And so this particular methodology really builds on frameworks associated with cooperative work. If you could move to the next slide. So if I think about the structure of healthcare work, in a sense, as we look at the structure of workflow, and in this case, this slide is specific to an example in an emergency department. So that's what ED is standing for, the emergency department. If I think about that structure, I have sort of in the first column indicated that there are different staff members who are potentially playing different roles. They're one aspect of the structure of the flow. The other aspect of the structure of the workflow that is highlighted here is I have patients, and then kind of the third aspect is that the staff members do activities that are related to patient care, and those are the boxes in the column. So if I move to the next slide, the traditional way of kind of thinking about and studying workflow is to consider the tasks and activities that a particular clinical role might perform. So, for example, I might study the system and I might look at what nurses do, and I might follow what nurses do and look at that. Or I might look at what physicians do and follow and look at that. So the view is looking according to what tasks and activities the physicians are doing. And as I then go to think about work as a whole and thinking about the workflow, I may try to integrate those different perspectives. But the initial frame that I have is to look at the parts rather than to look at how they fit together. So in contrast, going on to the next slide, in the patient-oriented workflow approach, I'm following what's happening to the patient. So it really does look, in the way that it frames the problem, at how these different tasks and how the roles of different people fit together to provide patient care. So now I'm going to turn over the discussion to Mustafa, who's going to describe an example of using a patient-oriented workflow approach in a study of emergency departments, and then he's going to talk a little bit more generally about the methodology.
Thank you. Can we move to the next slide, please? We conducted a non-experimental field study to test the idea of patient-oriented workflow, and the study included systematic observations of patient care interval until the first prescriber order. Prescriber here is either a physician or a mid-level clinician. To enumerate the range of activities involved in emergency department work, three well-established observation strategies were employed together. Patient shadowing, clinician shadowing, and clinic observations. Patient shadowing is observing a patient and relocating as the patient moves to preserve the site. Clinician shadowing is observing patient care activities by a clinician while relocating as the clinician moves to preserve the line of sight. Clinical observations can be defined as observing all the activities related to a specific patient care episode that happened within a defined section of clinical environment. And I developed an observation protocol that blends all these three techniques. All our study settings were located in the same county in Wisconsin, and they were non-academic hospital emergency departments. We captured a total of 108 episodes. Next slide, please. This is the observation tool we have used. The upper left button group is used to enter role information. An optional freestyle text can be entered in the big box in the middle, and activities are recorded using the button groups on the right. The entries are time-stamped, so we can create the sequences. Next slide, please. What does the data look like? Here you see two of the episodes we observed. Basically, we captured patient episodes as a sequence of activity role pairs. So each step includes a role and an activity. For example, in this example, episode 1 starts with registration by administrative staff, then an assessment by triage nurse, assessment by nurse, and assessment by mid-level clinician, and order by mid-level clinician. As I mentioned before, this is the first patient-driven order by a prescriber. So we captured, so when I talk about episode here, we really captured only the early stage of the whole care. When we look at episode 2, which is on the right, there are some common activity role pairs with episode 1. However, they are not identical. Next slide, please. This table describes the sample we captured in the study. 108 patient care episodes were observed. 94 of them were walk-in patients and 14 ambulance patients. Duration of these episodes ranged between 10 minutes and almost 3 hours. Number of steps in a single patient care episode ranges between 4 and 11. One interesting finding is that the number of unique sequences observed is 96, considering that the sample consists of only 108 episodes. Observing 96 unique sequences shows a high level of variability. Next slide, please. When we look at the frequencies of the 96 unique sequences, 88 sequences were observed only once, 5 sequences were observed twice, and only one sequence combination was observed 4 times. Next slide, please. So I just want to remind you again, when I talk about episodes, we capture only the early stage of the whole length of the emergency department. So, looking at each workflow separately is effective to understand the episodes individually. So we can understand how activity role pairs occurred over time. However, this representation, like individual representing individual workflows, should be improved to see the multiple episodes together. And I combined episodes in a way to highlight similarities and differences across the episodes. And Shiragi, if you show the second half of this. Yeah. So in the case of these two episodes, both episodes started with the same activity role pair, which is registration by administrative staff. The second activity, which is assessment by triage nurse, is also same. But the third activity was different. Then I represented the difference, as you see on the right merge diagram, was shown by branching out. So one of the episodes then continues with assessment by nurse, and the other one continues with assessment by triage nurse, which will be second triage nurse for this specific episode. Then the fourth activity is same in both episodes. The second episode includes a status update activity here, and both episodes end with an order by mid-level clinician. Here you see I also tried to align similar activity role pairs. Ideally, I would love to show the 108 episodes on a single page. However, it was not practical due to space limitation and the space limitation. I had collected my data in 3 rounds, so I visited emergency departments at 3 different time frames. And given that I conducted observation at 3 different emergency departments, I grouped all the workflows I observed in the single round and single emergency departments. And then I created 9 workflow groups. If you move to the next slide. So here you see an example of one of the workflow groups. And what we see here is the 9 episodes visualized all together. Next slide, please. So the boxes with the bold lines together, for example, make up one of the episodes observed. So it starts with assessment by triage nurse, registration by administrative staff, assessment by triage nurse, and goes on. And if you move to the next slide, so we just see another episode here. When we look at the graph together, we see that no sequence combination was repeated, and 5 of 9 episodes represented here started with assessment by a triage nurse. 3 of them then were followed by a registration by administrative staff. Next slide, please. The visualization of patient care episodes reveals variability in terms of sequence of activity role pairs. This is consistent with what I mentioned in descriptive statistics. Please remember that I mentioned that there were 96 unique sequences within 108 episodes. However, visualization shows that some of the unique sequences are similar to each other. None of the 96 unique sequences is identical to any other, but there is some similarity that will help us to identify some patterns. The next step of data analysis concerns identifying the patterns by quantification. Next slide, please. How to quantify workflows. So this is the slide I have already showed you before. So can we quantify each of these workflows? I don't know, but I found out a way to quantify the dissimilarity between any two episodes. And we can measure and quantify dissimilarity by counting minimum number of operations required to transform one episode to another. In this case, for example, if I add a triage nurse assessment and status update activity to episode 1 and then remove nurse assessment, I will have episode 2. So basically, in order to convert or transform episode 1 to episode 2, I needed 3 operations. So then I can conclude that the dissimilarity between episode 1 and episode 2 here is 3. And I compared every pair of the 108 episodes and then came up with a 108 times 108 matrix. I'm not going to show you the matrix here, but if you move to the next slide. This is the projection of the huge matrix on a two-dimensional space. This diagram shows all the 108 episodes. Each dot is a patient care episode. Closer episodes are more similar to each other. The figure shows that patient care episodes are grouped in 2 clusters. The first group is located on the left side of axis 0 line. If you move, if you show the first line, should I get? Yeah. So, for example, you see the red line on the screen, and this red line divides. It shows the division of the 2 groups of episodes here. And when we look at both groups, we see that these groups include more concentrated data points above y-2 line and more scattered data points below y-2 line. If we show the second red line, yep. So after noticing this pattern, we look closer to data, and then we notice that all the episodes on the left represent episodes where the patients were cared by a mid-level clinician, and the episodes on the right represent the episodes where clinicians were cared by physicians. So one distinction here is who cares for the patient. On the both sides, the clumps, clinic episodes are walk-in patients. So they are closer to each other, so they are more similar to each other. And scattered episodes on the south show the ambulance patients. And then our obvious initial conclusion here was that the primary source of workflow variability is type of provider, and secondary source of variability was the arrival mode. And the next slide, please. So what can we learn from using the patient-oriented workflow approach in emergency departments? Several experts already have noted the high-level variability of ED work. However, patient-oriented workflow allows us to characterize the nature of the variability. We developed a distance matrix, a dissimilarity matrix, quantify the workflow variability. Quantifying workflow variability allows systematic evaluation of the procedural aspects of the patient. care steps that can be compared across various emergency departments and within one emergency department across various situations. Moreover, pre- and post-intervention workflow measurements can be developed to show the impact of interventions on patient care. Understanding sequence patterns can be beneficial for emergency department work environments because, for example, providing tools and information to clinicians at appropriate moments or enabling them to overview the work process they are part of may increase their efficiency. The high level of workflow variability reported in this study suggests the importance of flexibility in emergency departments. Emergency departments need to be flexible enough to cope with daily demand changes as well as make adjustments dependent on the type of patient entering the system. Lack of flexibility can increase the duration of episodes, lower the capacity of emergency departments to respond to increasing patient load, and lead to overcrowding. As engineers, when redesigning work systems in emergency departments, we should make sure that flexibility does not suffer due to our engineering intervention. When we look at as an example, the information technology interventions, the main reason for lack of adoption has been technology interventions leading to rigidity. Next slide, please. And also, by using a patient-oriented workflow approach, we were able to depict involvement of multiple staff members working together. And also, because we are looking at a more meaningful, we are using more meaningful system boundaries, such an approach can lead to quality improvement initiatives that is more consistent with the cooperative workflow and its emerging features. Next slide, please. Despite the various benefits of utilizing patient-oriented workflow, significant challenges exist. Practical challenges include difficulties with conducting workflow studies in real clinical settings because these places are typically very sensitive places. Methodological challenges include reliability and validity concerns of the collected data due to a high level of variability and complexity in clinical settings. Theoretical challenges include the lack of comprehensive, robust conceptual frameworks that can be used to guide patient-oriented workflow studies. Additionally, patient-oriented workflow involves a larger scope and includes more complex work phenomena. We probably need better modeling techniques to overcome or to address this escalated level of complexity. Next slide, please. We claim that the patient-oriented workflow methodology is appropriate conceptually and methodologically to study patient care as a result of cooperative work. Research and practice community can benefit from the methodology and its methodology to study patient care, not only in emergency departments but also in other care delivery settings. So here in this slide, we propose some steps that can be taken to apply patient-oriented workflow approach. The first step could be identifying the boundary of the system. These boundaries can be in time, in space, in process, or hierarchy. Identifying appropriate boundaries is important because of these boundaries. If these boundaries are too narrow, an essential part of the cooperative work can be missed. If they are too broad, the focus will be lost and study might consume unnecessary resources. The second step could be identifying and developing an activity theory. Throughout a preliminary and exploratory study, activities that are conducted to meet the needs of a patient can be identified and categorized by using activity theory. And I'm particularly suggesting activity theory here because it accounts for not only behavior but also goals. So what is the motivation or goal of an activity? And the third step could be developing a role category. So role theory can be used to develop the role categories. And then, of course, we can also capture some other additional variables, you know, for example, health status of patients. So if we want to understand, let's say, the impact of workflow on the patient outcomes, we should also collect data on the health status of patient. And the fifth step could be identifying data sources and data collection protocol. And the last step would be analyzing data. And once the data is collected, it can be analyzed by using various data analysis techniques such as descriptive statistics, visualization, and or the more advanced quantitative techniques. And I think what is important here is to use the unit of analysis should be single patient care episodes. Thank you very much. Actually, that concludes our presentation.
So we'd like to open it up for questions and discussion.
So this is Sharon and Mustafa. This is Jim Schlosser. So the insight from the analysis of the ED suggested that there were two major factors. One was either mid-level clinician or physician, and the other was the arrival mode that sort of helped differentiate into those four major categories. So given that insight that physicians and mid-levels have some differences in their process, and patients who arrive either walk-in or by ambulance might have major differences, what then would be the insight, how would we use those insights to understand or improve the ED patient flow?
So I can think of a couple of different ways. The first of all, these four different situations, like the very general patterns. So when we develop systematic interventions, we should definitely test our intervention for these four different situations. That can be one way to use this insight. The other one I'm planning is to develop, for example, when we develop emergency department simulations, we need to simplify the complex phenomena which is ED work here. And understanding these four main categories can allow us to simplify work more accurately.
Great, thank you.
Thanks for the question.
I have a question. This is Janice Hirsch. So I guess my question is, how would you contrast the patient-oriented workflow versus process workflow that some of us might map out if we're trying to work out a current state in a clinical or administrative setting? Would it be useful to overlay the patient-oriented workflow in addition to gather more information? I'm wondering how you would see the practical applications of this.
Thank you. Actually, that's a great question. And the patient-oriented workflow is a way to look at work in clinical settings. And so it's not the only way to examine the work, clinical work, or non-clinical healthcare work. But this is a one alternative and relatively not much utilized way to study work in clinical settings. And we would like to highlight some advantages of patient-oriented workflow, for example, ability to capture cooperative work. But on the other hand, of course, some other methods like the clinician-oriented workflows, they are also useful and they should be used in complementary way.
And Janice, from a sort of process and building a sort of a process map point of view, one of the things that you often want to try to capture is some of the variation that occurs in the process. And I think because you're looking in this methodology at specific patient care episodes and then sort of explicitly capturing the variability in those episodes, it kind of gives you a way of doing that. So I think it's consistent with process mapping, and it looks kind of, in our picture, horizontally instead, actually in our picture it's vertically. It looks across, the different roles to see how they're doing work in the same way that a process map might, but it sort of explicitly is trying to capture the variability in how those tasks and activities get done.
Okay, that's very helpful because it's hard to get that, I guess, without a lot of observations.
Right.
Yeah.
Right.
Okay. All right, that's interesting.
Yeah. On your slide 20, would you mind explaining the X and the Y once again, please?
Sure.
I'm going to pull it up.
So, just a quick background information. So, this is I was able to produce this graph by dimension scaling, dimensionary scaling. So, this is 108 times 108 matrix distorted appropriately so that it can be shown on a two-dimensional space. And initially, the axis, like the x-axis and y-axis, they are abstract. But by looking at data, we can interpret what they mean. And in this case, when we look at the x-axis, because the episodes on the left, they are mid-level clinicians, on the right, they are the physicians. So the x-axis here shows type of provider. And the y-axis here shows arrival mode, because the ones on the north, they are walk-in patients, and the one in the south, they are ambulance patients.
I see. So the 108 by 108 matrix that you reduced to get this, the entries in there are basically the dissimilarity scores that you talked about on the slide before.
So each cycle here is an episode. Each cycle, like each dot circle, each circle shows an episode, and the distance we see here between circles is the distance, like the dissimilarity between these two episodes.
I see. So between episode 1 and between episode 3, the dissimilarity score you mentioned on the previous slide would be what score you give?
Yeah.
Okay. And then in order to see it on the two-dimensional space, to categorize them into similar categories, this is the reduction you did to show that. And by looking at how they divide on this space, you were able to show that the clinician type, for example, is one of the important axes.
That's correct.
Okay, thank you.
Thank you.
Hi, this is Nancy Leitner from the IndieVerk, and this is very interesting, but I'm wondering whether a parameter of an episode was the source of the injury. For example, did you look at automobile accidents versus stroke?
I think this is a great question. So No, we didn't collect data about the type of health problem the patient was coming, but this might be important as well, and actually this is one of the future studies we plan. But we didn't collect data for this specific study. We didn't collect data on the patient health status and patient health outcomes.
Thank you.
This is Jordan speaking. I actually just on that point about what they came in for, one of the big issues that we had with my research was coding that primary complaint, which can be a big pain, and that's actually future work that we might be doing with MITRE in terms of creating a natural language processor. So hopefully if that moves forward, I'd love to be able to share that with you guys and see if that's a direction you wanted to take it.
Yeah, we would love to see that. Yeah. Thank you.
It's interesting, yeah.
Are there any more questions?
Just as a kind of concluding remark, kind of building on a question that Janice had asked earlier and thinking about, systems in general, I think there's this challenge in healthcare. We either think of it sort of this, everybody is the same or everybody coming in is different, right? So that you have sort of minimal variability or maximal variability. And I think, as you look at patient-oriented workflow and you capture these, the variability in patients, and then you analyze the data. And so when you look at Mustafa's study looking at EDs, he's analyzing the data to come up with significant patterns, which help, I'm now not thinking of the system as just one, but as 4 streams in this case. But I'm not thinking of it as an infinite number of streams, which when you first look at the sequences, it does look like that, almost every sequence is different than any other sequence. I think that's really powerful as you start to do sort of process analysis. And so I think it's a very exciting technique for that reason, is that it helps to capture that balance between, trying to represent the variability in a way that is important to the system, but also allows you to model the system and understand the system.
Great. Thank you, Sharon and Mustafa, for sharing your thoughts today on a very interesting topic. If there are no more questions from the audience, I just wanted to make one quick note. I hope you'll join us. I hope you enjoyed today's discussion and hope you'll join us for next month's seminar series. We have Gina Glover from the MIT who's going to be presenting on critical factors for sustaining Kaizen event outcomes. If there's nothing else, then I think we will conclude, and hope you have a great rest of the day, and thank you very much for joining us today.
And thank you for having us as well.
Thank you.